the application, I already have the UI set up with a button that when I click it, what I want the code to do is throw an unhandled exception. Currently that's not happening. Let's wire that up really quick and then observe the results. So on this throw exception button, I will use ngClick to tell my model that I want it to create an exception. So I will need to take this expression and go over to the error-prone controller and add that as a method to my model here. So model.createException will be just as easy as doing throw new error, and we could put a message in here like something has gone terribly wrong. And let me save everything, come back to our user interface, do a hard refresh, open up the developer tools with F12, and make sure I'm on the console, and now click throw exception. You'll notice that in the UI that the user typically sees, there's no indication that there was an error. The average user will have no idea that something went wrong, but as a developer with my browser tools open, I can see there was an error raised at model.createException. So the goal of this video clip is to get that exception onto the screen, or at least let the user know that something has gone wrong. And this may be the type of behavior that you don't want active all the time in the application. You might not want every exception to go to the screen, but you do typically want to know about these unhandled exceptions because it means something has gone wrong inside of your application. So what's happening behind the scenes is that any callback that Angular invokes is the result of a directive. So the response to an ngClick or a mouse over, or the response from a $HTTP call, Angular is going to call into your code inside of a try-catch handler, so that if your code throws an exception, Angular will catch that exception and is going to pass that exception off to a service known as $exceptionHandler. So if we want information about what exceptions are occurring inside of an application, one approach we can use is to decorate $exceptionHandler. Now, I already have a file in place and loaded into the page called exceptionhandler.js. I just need to write the code inside of here that will register a decorator for the exceptionHandler service. And I want to decorate that service. I don't want to replace it, although I could. I just want to decorate it so that I can allow Angular to handle its exceptions using its normal course of actions, but I also want to know about those exceptions. So I'm going to provide a wrapper for the service, and any exception that Angular hands off to the exception handler, I will also see that exception. So the way to create a decorator is to create a config function for your module and give Angular a function to execute for the configuration phase, and this function will take $provide. You might know that you can use provide to create services, configurable services, but you can also use provide to create a decorator. And when you provide a decorator, you provide the name of the service that you want to decorate. So in this case, I want to decorate the built-in exception handler service, but I can decorate any service that Angular knows about. And then I provide a function which will return the decorator. Now the object that I return has to essentially be greater than or equal to the original service. In other words, if I was decorating the $log service, I would need to return an object that looks just like $log to anyone that's using it. And because the log service has 4 methods, .info, .warn, .error, .log, I would need to provide an object that has at least those 4 methods. I can add more methods that I use for my own code, but I at least have to provide those 4 methods for existing clients to be able to use. In the case of exception handler, this service is an object, but it's a function object. So I need to return something that is a function that other pieces of code can invoke. That's what everyone expects when they get an exception handler. That's what it is documented as. It's a function. And the exception handler service is also documented as taking 2 parameters. So this function takes 2 parameters. The first one is the exception that was thrown, and the second parameter is the cause of that exception. And so now the question is, what do I want to do with this information? Well, I do want to call into the original exception handler service and allow Angular service to do whatever behavior that it does by default. And I'll be able to do that because the first parameter to this decorator function is a parameter we'll call $delegate. And that parameter always represents the original service. So if I was decorating $log, delegate would be the log service. I'm decorating $exception handler, so delegate is the exception handler service. Since that is a function, if I just invoke delegate and pass it the exception and the cause, I've now provided a decorator that just passes information through to the original service. I haven't added any additional behavior, But if I save everything and refresh my UI, hopefully we won't see any errors about that until I throw an exception. I just see the original behavior. So now my goal is to add additional code inside of here so that I can see something on the UI. I want to pass the message associated with that exception to the alerting service so it can put something onto the screen. So let me show you what happens if I inject the alerting service into this decorator function. Now I will do a refresh, and you'll notice we get an error in the console window. It's circular dependency found. Root scope, timeout, alerting, exception handler, root scope. This is an error that you might commonly see when you're decorating low-level services from Angular. It's basically the injector's way of telling you that it cannot instantiate this particular chain of dependencies because there's a circular dependency. Alerting depends on timeout, which depends on exception handler, and it just goes around in a loop. So there's a number of different ways to solve or break that circular dependency. But one surefire approach to do that is to not inject the service that creates the problem, and instead inject the injector itself. That is the IOC container that's inside of Angular. It's the service that does all the dependency injection. But I can use that component to get to my alerting service. I can just ask the injector to please get me the service called alerting. But notice I'm doing that inside of the decorator function, so that piece of code is going to execute later than this function that creates the decorator. That's what's going to allow this to work. So I will use the injector to get to the alerting service, and then I will tell the alerting service to add a dangerous alert using exception.message, which you might have to play around with a little bit. There's no guarantee that message is going to be there, because JavaScript code can throw anything. You can throw a string, you can throw a number. The best practices will say to throw an error, but you might be using a library that doesn't do that. So you might need to do a little introspection on this exception before you try to dig out some sort of message or reasonable explanation for it. Now that I have those two lines of code in here, let's save this and come back out to the UI and do a refresh. And now I want to throw an exception, and I can see that appear in my UI. I can also still see it in the console window, but that's only because I called into the original exception handler. So hopefully this shows you some of the value in decorating a service. I'm sure you can think of other uses for the information that you get inside of this particular decorator. You could, for example, send that information back to your home server to collect information. And this is just one example of a decorator for exception handler. Let me show you another interesting decorator.